Hi, and welcome to the GIS Center's Lunches Learn series. This is the third in the series, and it's titled So You Want to Become a Raster Master. My name is Jennifer Strang, and I'm a GIS analyst at the Dalhousie University Libraries.
Before you start, this presentation assumes that you have ArcGIS Pro set up on your computer. This is a Windows-based software that can be downloaded from Dalhousie's software download site. Note, the version that we're using in this presentation is going to be 3.5.1. If you don't have ArcGIS Pro loaded on your machine, it is also available on all the Windows machines available in the library, as well as various classroom labs around the campus.
The agenda for today's session, I'm going to introduce and compare the two main data models in GIS, Vector and Raster. Next, we're going to talk about the types of raster data. Then we're going to talk about cell values and size and how the size relates to the resolution of the raster. Then we're going to do an exercise to find a site selection for a picnic area in Cape Split. So what happens if I have questions? Please feel free to ask the questions throughout the session. Just ask them in the chat screen. If it's something that's general to the class, then I will answer it publicly to everybody. If it's something specific to you, then I will open a separate chat window and speak with you personally. Remember, there's no such thing as a stupid question. If ever there was one, I probably asked it. The only thing I ask you to remember is answering questions through chat can be a little more time consuming than doing it in person, so just be patient if I don't get to you right away. The learning objectives for today's session. You're going to learn about the two different types of geospatial data. You're going to learn about the advantages and disadvantages of each of the two data types. You're going to learn how each of the data types represent real-world objects. We're going to talk about how cell size affects resolution and file size. We're going to identify the various types of raster data. And then we're going to do some mathematical combination of this raster data to help solve problems. So when you're representing geographic features, there's two main models that are used. There's the vector model, and this uses discrete X and Y locations to represent geographic features. So basically everything in a vector model is a point, a line, or a polygon. This is compared to the raster data model. In a raster data model, the world is represented by equally sized square cells to represent features, okay? And each cell would then have a value. Some examples of raster data model would be things like air photos, satellite imagery, or digital elevation. So how do raster and vector formats compare? We'll start with the vector. Vector is really efficient for very sparse data sets. So if you only have a couple of features in a large area, vector is likely the more efficient way to store that. It tends to be more precise or appear to have a higher resolution than raster data. It tends to deal really well with exact boundaries, but the processing times can be high with complex data sets. And what is a complex data set? Well, that would be ones that have a lot of attributes associated with them, or potentially have a lot of polygons that are associated, or points or lines associated with them, or they can be very complex, lots of vertices defining your lines or polygons. Rasters, on the other hand, they have to have a predefined resolution before you start. It's a really efficient way for storing dense data sets, but it deals poorly with linear features, and that's because you have to be on a certain angle because everything's represented as square, so it's hard to show lines when they're made up of squares. Okay? And probably the biggest difference is there's only one attribute value per layer. So if you think about vector and the example from our introduction a few weeks ago, our hotel had a number of attributes. It had a name, it had a phone number, etc. When you're dealing with raster data sets, there can only be one attribute per layer. If you want to store multiple attributes, you would need to store multiple layers. So let's take a look at how points, lines, and polygons would look if you represented them in raster. So you can see here our points. We have 3 points, and it would be represented in a raster of number of cells, only 3 of which would actually have valid values. The rest of those cells do need to exist, but they wouldn't have an actual value in them. They'd have a no data value associated. But every single pixel would need to be there to be read properly. Take a look at the lines. So in this might be a river that we're looking at, and you can see it doesn't deal nearly as well with lines as it does in, it does much better with lines than it does in raster. You can see we don't have the same level of detail. Yes, it could be argued you could make the squares smaller, the grid cells, and it would more accurately follow your river, but it's never going to be as crisp looking as it is in the vector. And the final example is taking a look at a polygon and showing what that would look like in the raster world. So remember, in the raster world, you need to have everything has to be inside of a square, and those squares will have some sort of value. It could be a no data value, or it could have some value of meaning. So in the case of the lines or the polygons or the points, those purple squares would have some sort of value. What are the types of raster data? Well, they can be divided into 2 main classifications, thematic rasters or image rasters. Thematic rasters represent geographical features or phenomena, can be discrete or continuous, but represent one distinct theme. That theme can be any number of things. One example might be elevation. It could be land use, but it's only ever going to show one distinct theme. Image rasters, on the other hand, are pictures that are produced by optical or electronic devices, such as cameras, satellites, and scanners. These image rasters then need to be interpreted, typically to be used for analysis within the GIS. So diving into discrete thematic rasters, this tends to be categorical data, has really well-defined boundaries, and depending on the type, could have associated values. So it's important to realize when using raster GIS, rasters should be numbers, or what's stored in the computer are numbers. Sometimes it will have an associated value indicating what that number means. So 15 may equal a land use type of recreation, okay, for example. But remember, there's only ever one attribute, and it's stored as a number in the computer, but there may be an associated text value that goes with it. So here's an example of what discrete thematic raster could be representing. So you can see on the top that you're trying to represent land use of a particular area. So essentially you're putting a grid on top of that and looking at the values underneath it. So in this particular case, you can see the farmland or agricultural is being represented by the number 37, whereas the industrial are represented by 81. If you then take that grid and you look at it top down, what would it look like? And that's what you see on the right-hand side. So you can see there's very distinct boundaries between the numeric values. You can see it's actually the numeric values that are stored in the GIS, but you can see that they're linked to some sort of text field. So in this particular case, you can see that 22 is recreation, 37 is agriculture. Okay, so if you query the individual cell, it's by default going to give you the number. There may be an associated value that goes with that that'll tell you what that number means. The second type of thematic rasters is continuous thematic rasters. So again, this is geographical phenomena that could vary at every single location on the map. Every cell, therefore, could potentially have a unique value. Some examples of data that's mapped as rasters like this could be elevation, temperature, cell phone signal strength, to name a few. So here's an example of what continuous thematic raster would look like if you're mapping a real world situation. So you can see on the left, we're trying to map the elevation of a particular area. Again, you're going to dump a grid over top, and you're going to find the elevation inside of each one of those cells. If you were to look at that from a top down and put the grid into a GIS, it might look like what you see on the right-hand side. So you'll see here, you don't have those hard, distinct boundaries that you had with the discrete thematic rasters, okay? There's a continuum of values, okay? And in this particular case, each one of those cell values have a particular elevation that's associated with them. So there are no hard boundaries when you're talking the continuous thematic raster typically. So next we're going to speak about image rasters. As I mentioned, they're produced by optical or electronic devices, and they typically are going to require interpretation before they can be used for analysis within a GIS. If you look below, you can see two images. The one on the left is an air photo. So if you look at that, you can probably see, okay, there's some buildings in there and there's some roads, but you can't actually do anything with it. It's a picture unless you start to interpret the information that's in there. Okay. The data on the right is an example of a piece of a topographic map, and you can see there's some contours on there and some numbers. And again, somebody would need to interpret this. So you can tell that there's a contour, and contours are lines of equal elevation, but there's no way to tell the computer this by default. It has to be interpreted after it's been scanned in. When working with raster data, one of the main differences between that and vector data is you only have one attribute per layer. Okay? But what happens if you need to identify a class or a category or a group of cells? Okay, so to do this, you typically have a layer, a raster layer, that will be divided into either zones or regions. So what is a zone? A zone is a group of cells that have the same value, but they don't necessarily have to be adjacent. So for instance, if you wanted to identify all of the balsam spruce tree stands in a particular area, you would then identify which zone, which would be clumps of areas that may or may not be connected, okay, that would identify the balsam fir. Regions, on the other hand, are groups of cells that have the same value again, but they must be adjacent. So regions tend to be used if you need to find flow or movement. So these cells need to be connected in some way to move along or through them to from one area to another. So here's an example of a raster that could help define various areas within your map. So in this particular example of raster, you have values 1 through 4, 1 representing water, 2 representing wetland, 3 forest, and 4 beach. The cells that show value 2 would be an example of either a zone or a region. So in our case, we only have one area, so it is contiguous, and you can see there's some connectivity there. So it can be a region, but it can also be a zone. The cells with the value 1, which is the water cells, would be an example of a zone. So you can see there are 2 separate areas that have the value 1 inside of it. Cell size. If you're creating raster data, it can be any size that you define it to be. Smaller cells have higher resolution, so there's far less generalization. But these smaller cells can mean larger file sizes, which can mean a lot longer processing times. Larger cells, on the other hand, have less resolution, therefore more generalization, but can run much, much faster. Ultimately, you need to balance the application needs with the time, the size, and the space limitations that you have available. So what about cell size and how it could represent a feature, okay? And how accurate is that to the actual feature that you're trying to represent? So in this particular example, you can see we have a polygon that we're trying to represent. In the 400 by 400 meter cells, you can see it doesn't actually capture the shape very well at all. If you actually calculated the area for those cells, it would be 1,120,000 square meters. Okay. The problem is the actual size of the polygon is 855,546. So you can see there's quite a big discrepancy. It's not representing the shape well, so there's some issues. Okay. If you take a look at the middle example, these would be a representation of 200 meter by 200 meter cells trying to represent that same polygon. In this case, you can see the shape looks a little bit closer to the polygon we're trying to represent. You can also see that the area although not perfect, is getting better and more similar to what the actual area is. Okay. If you look at the final image, that's the 100 meter by 100 meter cells, it's actually doing a pretty good job at representing the shape of the polygon. And you can see the area is actually much more closely representative to what the actual area of the polygon is. It's really important when you're using raster and you're converting your data, if you are converting it from vector to raster, that you consider the ramifications of the cell size and what you're trying to represent and the time it's going to take. So you can see the size on the 400 by 400 meter going from 400 to 200 doesn't just double the size, which is what you probably think by default, but it literally quadruples the size. So if you take a look inside each cell, instead of just dividing in 2, it actually gets divided by 4. So this is really going to make your cell size a lot bigger. And that does need to be a consideration when you're working with raster data. Next, we're off to Cape Split. We're going to try to plan the perfect picnic spot on Cape Split. In case you've never been to Cape Split, I thought I'd give you an idea of what it's like. So Cape Split is located in the Minas Basin off the Bay of Fundy between Nova Scotia and New Brunswick. As you can see from the pictures, there's one side that is quite steep. The other side is much more gradually dipping, which is the Nova Scotia side. The steep side is kind of facing towards New Brunswick. So the scenario we want to look at is we want to identify the locations in the Cape Split area that would be suitable for a picnic area. Okay, and ultimately we like to display this over a hillshade. So what have I defined as the perfect picnic spot? Well, I'd like it to have a slope that's less than or equal to 5 degrees, so I don't want it to be super hilly. Otherwise, the picnic table doesn't stay flat. I'd like there to be suitable tree species. So personally, I find the hardwood trees or the deciduous trees to make for a better picnic area because you can get some shade and they tend to be a little less buggy than the coniferous. So the suitable tree species we're going to look for specifically are tolerant hardwood and unclassified hardwood. The other thing I'd like to look for is suitable tree maturity. So there's a potential that we might have to take a couple trees down in making our picnic park. So if we have to take them down, we want to make sure they're harvest ready. We wouldn't want to go into something that would be considered old growth or something that has very young growth that maybe somebody's just planted. So ideally, we'd like the trees to be have the maturity of harvest ready.
Now we're ready to get started. So a bit of a quick word about how I run these sessions. You're going to notice that I'm going to explain first in words all the steps that we do. The next slide, when we get to it, is actually going to show you how these steps look or where you find the various buttons that we talk about. So to start, we're going to begin by opening up the ArcGIS Pro software. So to do this, you're going to go to the search button at the bottom of your screen next to the Windows icon, and you're going to type in ArcGIS Pro. Then you're going to select ArcGIS Pro app. It'll take a moment or two, but the software will open. Once it opens, you're going to go to the new project area and you're going to select Map. This is going to bring up a pop-up window. And under the project name, I'd like you to enter Cape Split. Then I'd like to choose a location where you want this project to exist. It's really important to pay attention to file management and where things are going, so do pay attention to this location. Then I'd like you to download and unzip or uncompress the data. So you should be able to access the zipped up data from the link supplied. Then I'd like you to either unzip, uncompress, extract, they all mean the same thing, using whatever software you have on your machine. And I'd like you to put this in the project folder you just created. Remember, that's called Cape Split. So here we are on our main screen. Down here beside our Windows icon, we're in the search bar, we're going to type in ArcGIS Pro. Okay, you'll notice that there is a match here and it's the ArcGIS Pro app. I'm going to choose to select that. It'll take a moment or two for the program to open. It is a big program, but when it does, we're going to maximize our screen here. Under New Project, we're going to choose the Map option. So we're going to create a new map project. So the name I'm suggesting you enter is going to be Cape Split. You'll notice that I have no special characters or spaces in this name. Often best if you try to avoid those. Then under the location, I'm going to use the browse button and pay attention to the location where I want this new project to exist. Again, file management is really important for GIS. So in my case, I have a location in my downloads folder for Lunchless Learns that I created. So again, I'm going to just scroll down to Lunchless Learns. Okay, and I'm going to click the OK button. And you'll notice what it's going to do is create a new folder called Cape Split in this location. And then I'm going to click the OK button. It'll take a moment or two, but it'll start with a new empty map project. So now what I want to do is I want to unzip the data that we just created into this Cape Split folder. So again, I've created this Lunchless Learn folder, and you can see here is the data. I'm going to extract it or uncompress it. I'm going to right click on it, and you can see there's an extract all program on my machine. And it's asking me where I would like to extract the data. I'm going to browse because I want it inside of this Cape Split folder. So I'm going to use the browse button here. And then I'm going to, again, we're going to go to the downloads, Lunchless Learn into Cape Split. And I'm going to select that folder and I'm going to choose the extract option. Okay, so now if I go inside of Cape Split, you're going to notice that I have this Lunchless Learn raster.gdb. This is what I just unzipped into this folder.
Now we're ready to add our data to ArcGIS Pro. So to do this, you want to be on the Map tab in the Layers group and click on the Add Data button. You need to go to the Lunchless Learn raster.gdb. Again, that's going to be wherever you unzipped the file. Okay. I'd like you to select all three raster layers, DEM, species, and maturity. If you hold your control button down, you can select them all at the same time. Then click the OK button. If it asks you about pyramids, you can simply say no. If you said yes by default, don't worry about it. I'll explain a little bit about what they are. So what exactly are pyramids? Well, when you look at a raster data, particularly if it's very large, you're unable to see all of the details that are actually there, and it just takes up a lot of energy and time trying to get your machine to show every single pixel. So what ArcGIS Pro does is it creates lower resolution versions of your data, and it will show you the lower resolution depending on what zoom level you're currently on. It's important to note, regardless of whether you build pyramids or not, when you do analysis, it's always doing it on the most detailed data. Now, the reason I suggested you say no at building pyramids is the data set we're using is quite small, so it doesn't take a lot of time to generate, and it just takes time to make these multiple images. So there's no real advantage in this particular example with such a small data set.
Now that we've created our project and added our zip data in, we need to add that data into our project. So I'm going to start by closing our File Explorer here. I'm going to go to the Map tab up here at the top, and I'm going to choose the Add Data option. Then I need to find my data. Because I put it into our project folder, I can just click on the folder option over here. Okay. And then you can see there's Cape Split, so I'm going to double click there. And you can see here there is our Lunchless Learn raster.gdb. That was the data that we extracted. So I'm going to double click on it over here on the right hand side. You'll notice there's 3 layers. I'm going to select the first one. I'm going to hold my shift button down and get all 3 of them. And then I'm going to click the OK button. If it comes up with a message about building pyramids, you can just say no. Although if you said yes, that's not a problem. It just might take a little longer for your data to show up. Okay, so again, here's asking us to build this, and I'm going to always use this choice. So I'm going to just say no, I don't want it to build pyramids for me. And you can see it's added all 3 data sets here. So you can see on the left-hand side, I have species, maturity, and DEM. If yours are in a different order, don't worry about it. It just happened to be the order that I selected based on, okay? So that not to worry if it's in a different order than mine is. Step 3 is to create a slope map. But before we start, it's important to note there are additional tools in ArcGIS Pro that require additional licensing. These tools are grouped into extensions. To do analysis with Raster, you need to make sure that you have access to the Spatial Analyst extension. So how do you do that? You're going to go to your Project tab, and then you're going to go to Licensing. You're going to review the ArcGIS Pro extensions and make sure that the Spatial Analyst option is licensed says yes. And then you can use the back button. And then we're going to turn off the species and the maturity layers by unchecking the boxes next to those in the table of contents. So the first thing we're going to do, because we're going to be doing analysis with raster data, is verify that we have access to the Spatial Analyst extension. To do that, you're going to go up here to the Project tab in the upper left corner. You're going to click on that. You're going to click on Licensing. And you can see mine was already there. But under the ArcGIS Pro extensions, you're going to scroll down and make sure you have access to the Spatial Analyst. So you can see that the Spatial Analyst license is licensed for me. And this should be the case for all people at Dalhousie because of the way we've set up your licenses. But if you go out into work with another company, it's important to realize that they may or may not have the Spatial Analyst extension, which means you may or may not have access to these additional tools. So we're going to use the back button up here in the upper left corner again, and then we're going to select off to turn off our species and our maturity layer. So we're just going to uncheck next to species and uncheck next to maturity. And if you want, you can even uncheck our base map here, which is our Canadian accessibility and our world accessibility styles. Okay, so the only layer that we have on is our DEM or digital elevation model.
Looking at our criteria, we know we need to have slope that's less than or equal to 5 degrees. Looking at our data, we don't have any slope data. Turns out we can make slope data from the DEM or digital elevation model. So that's what we're going to do. So how do you create the slope layer? You're going to start by going to the Analysis tab, going to the Geoprocessing group, and picking the Tools button. You're going to notice the Geoprocessing pane appears on the right side. In the Find Tools, I want you to type Slope. Then you're going to select the Slope Spatial Analyst tools. In the new tool that opens up, enter DEM for the input raster, and for the output raster, type in Slope. Leave the rest of the parameters as default and click OK.
Next, we need to open the Slope tool. To do that, you're going to go to the Analysis tab here at the top. In the Geoprocessing group, we're going to choose the Tools button. And you're going to notice it opens up here on the left-hand side. And what we're going to do is the tool we're going to search for is going to be Slope. Okay, so we're going to type in Slope and we're going to choose the Spatial Analyst one. Okay, so for our input raster, we're going to choose our DEM. So if you use this little drop-down option here, any of the valid layers will open up. Okay, so again, we're going to select the DEM. For our output raster, we're going to call it Slope So we're just going to get rid of this end bit. And it's important to realize by default, it's going into your project geodatabase. So when you created your project, which we called Cape Split, it automatically created a Cape Split geodatabase. And that's where any new data is going to be created. Okay. Because we are looking for 5 degrees or less, we're going to leave our output measurement as well as the rest of the other parameters as they are in the default. And then we're going to click on the Run button. It'll take a moment or two and you can see that the slope map now appears.
Now that we have the slope layer, we need to figure out which of those pixels meet our criteria, which is less than or equal to 5 degrees. So in order to do that, we're going to use the Raster Calculator tool. To find the Raster Calculator tool, go to the Analysis tab, the Tools button again, and search for Raster Calculator, the Spatial Analyst. Just to understand what tool we're going to be using within the Raster Calculator, we can do lots of different things within it, but we're going to use the conditional statement. And the way the conditional statement works is you use the keyword con, and then in brackets, round brackets, you're going to type the condition you're looking for. In our case, it's slope that's less than or equal to 5. And then you're going to put a comma, and then what to do if it's true. Okay, so if it's true, I want you to put in a 1. So you're going to put comma 1. And then you can see there's a comma, and then in curly brackets it's showing the false expression. The curly brackets are indicating that this is an optional parameter. Okay, so we're not going to put anything in there. And what's going to happen is it's going to put a no data. So essentially our output is going to be ones and no datas, ones where it meets our criteria, which is less than or equal to 5 degrees, and no data where it does not meet that criteria. The output raster you're going to create is called good_slope.
When we take a look at our newly created slope data, you can see the values range from less than 1.72 all the way up to less than or equal to 90. Okay, the darker the color, the higher the slope. So you can see in this particular instance, the highest slopes are kind of on the north side of this particular peninsula of land. Okay, but ultimately we're not interested in all of these pixels. We're only interested in the criteria, which stated anything that was less than or equal to 5 degrees. So how do we pull out just the good bits of slope? Well, we're going to use a conditional tool to do that. To access this tool, we're going to again go to the Analysis tab up here at the top. We're going to click on our tools. You'll notice again the geoprocessing opens, and this time we're going to type in Raster Calculator. Again, as you type it in, we have a couple of options. Because we made sure our license was the Spatial Analyst, we're going to choose that one. Again, that's typically the tool you use for most raster options. And this is the Raster Calculator tool. This actual tool allows you to do many different things. In particular, in this instance, we're going to use the conditional statement. So the tool we're looking for over here on the left is going to be con, which stands for conditional. So again, we're going to scroll down. I'm going to double click on con. And when I do that, you'll notice that it automatically appears in this box. So what is the condition we're looking for? In our case, it's where the slope, and again, we got to be careful because we want it to be less than or equal to 5. And you'll notice I made sure that it was all on the left side of the comma. Okay, so the condition we're looking for is where the slope is less than or equal to 5. And again, because it was done in degrees, that is assumed. Then after the comma, what do we want it to do? So what is if it's a true statement? So we're going to tell it to put in a value of 1. If we wanted to put in a false value, we could put comma and a false value. But if we don't put 1 in, it's automatically going to put a no data in. So in this particular case, if it finds the condition we're looking for, which is less than or equal to 5 degrees, it's going to put in a value of 1. Else, it's going to put in a no data value. Okay, our output raster file, we're going to again just get rid of it here, and we're going to call it good_slope. Then I'm going to hit the run button. It'll take a moment, but it should highlight with just the good slope. Okay, so again, you'd expect these, in this particular area, it's gray. I'm actually going to adjust the color just to make it a little easier to see. So maybe I'll make it red. Okay, so these red areas, you're expecting to have the lowest slope, so less than or equal to 5. So if I take a look and uncheck this red, you can see it actually, the red is on the lightest color. Okay, the other thing we're going to do is do some other quick checks. So again, to do a quick check, I'm going to go to this map tab up here. I'm going to make sure I'm on the explore option, but I'm going to use the drop down. And instead of choosing topmost layer, I'm going to choose visible layers. Okay, so when I click on the red here, in my particular case, the pop-up will appear, and you can see the good slope here has a value of 1, which means it was less than or equal to 5, but the slope is in fact 2.89 in the particular pixel I picked, okay, which is less than 5, which is what you'd expect. Okay, so if I select outside of the red area, you can see here the good slope is actually no data. The slope itself is actually 11.1, which is greater than 5, so therefore it is not colored in. So it looks as though our tool has worked the way we expect it to.
So now that we found the good slope, we're going to now look for the acceptable tree maturity. So we're going to clean up our map a little bit just to make it a little more obvious what we're doing. So we want to show only the maturity layer. So I want you to turn off or uncheck the DEM, the slope, and the good slope layers in the contents pane on the left side. Then check maturity on. Next, we're going to open the con tool. So in the last criteria, we used the raster calculator, which has a number of tools you can apply. But the con tool is also a separate tool that you can run. So to find this tool, you're going to go to Tools in the Analysis tab, and you're going to search for Con, the Spatial Analyst tools. For the Input Conditional Raster, you're going to use the Maturity layer. For the expression, you're going to get the expression where maturity is equal to harvest ready. Input true raster or constant value. I want you to put in 1. So wherever it's true, we're going to put in a value of 1. The output raster we're going to create is good maturity. So very similar to how it worked in the raster calculator, anywhere that meets our criteria is going to have a value of 1. Anywhere that does not will have a no data value.
The next step is to find the acceptable tree maturity. So the first thing we're going to do is we're going to turn off the layers that we don't need. Okay, so to do that, we're going to uncheck good slope. We're going to uncheck slope. And we're going to uncheck DEM. And we're going to turn on the maturity. Okay, and I'll zoom out so we can see the entire area. Okay. So if you remember, our good maturity are those areas that are harvest ready. So if there's any old growth forests here, we don't want to cut those down for our park, nor if we just replanted some young trees, we don't want to take those ones out. So looking over here in the table of contents, or the contents panel over here, the harvest ready is this purple color. Okay, so what we want to do is pull out just this purple color. To do this, we're going to use the con tool again, but this way we're going to access it in a slightly different manner. So there's a tool that it just does conditional statements, unlike the raster calculator, which does many different tools. The con tool will only do conditional statements. So to access it, we're going to again go to the Analysis tab up here. We're going to go to the Tools, and in the geoprocessing panel over here to the left, we're going to type in con. Okay, again, there's 2 of them. We're going to choose the spatial analyst one. And here for input conditional raster, what is it going to be based on? Well, in this particular case, it's going to be based on maturity. Okay. The expression, what are we going to do is we're going to say where the maturity, and this is equal to, and we want to say harvest ready. Okay. So you can see any of the ones with the little red dots are things that have to be, or stars have to be entered. So what do you want to do if we find this condition to be true? Well, we're going to put in a value of 1 again. So people might ask, why do I put in a value of 1? Well, this is a computer science standard. So if you have a value of 1, it's considered a true value, and 0 would be considered to be false. You'll notice here that the false, what do you want to do if it doesn't meet this criteria? We're not going to put anything in. So again, you don't have to because this doesn't have a little red star by it. So again, by default, it's going to put in no data. So what are we going to call our output raster? We're going to call it good maturity. Okay. Good underscore maturity. And then we're going to hit the run button in the lower right corner. Ultimately, we're expecting for the purple to go away, which you can see it did. So what we're going to do is we're going to change this color, this gray again. So I'm going to click on this, and this time maybe I'll pick pink color. Okay, so if I turn this pink on and off, hopefully you'll see it's exactly where the purple lies. Okay. So it looks as though it worked, but if you do want to do a quick check, we can make sure our good maturity is turned on. We can zoom in and we can use our map tab and our explore option again, and we can click on the pink. And again, you can see the value is 1, the maturity is 4. So remember, rasters like to use numeric value, but if we click on it, you can see that value number 4 is in fact harvest ready. If I click on a color that is not, in my case, the pink color, you can see the good maturity is no data. The maturity value is 7. If we click on it, that means it has an uneven maturity. So again, it looks like the tool worked as we expected it to. So we can zoom out and move on to the next step.
Now we have 2 of our 3 criteria for our picnic park. Next, we need to find our acceptable tree species. So what I'd like you to do is turn off the maturity and good maturity by unchecking them in the contents pane on the left and turning on the species layer by checking it in the contents pane. Now we're going to look for the reclassify tool. So to do this, you're going to go to the Analysis tab, Tools button. You're going to search for Reclassify Spatial Analyst Tools. Now that we have the Reclassify tool open. So for the input raster, it's going to be the species that we're reclassifying. Under the reclassified field, it is also species. So remember that the raster always stores a number, but we're going to be actually using that associated value that goes with it, okay? And that's the species layer. Under the reclassification, you're going to click the unique button underneath the table. Then you're going to delete all of the items that are not tolerant hardwood or unclassified hardwood, okay? And then you're just going to hit the delete key on your keypad to get rid of them. Then for the new value, change them both to 1. So remember, rasters like to store numbers. So we wanted to store a value of 1. The output raster this time is going to be called good underscore species. There's a checkbox underneath for change missing values to no data. Make sure that is checked. So the ones that don't have a value will automatically go to no data. So the end result will basically be ones and no datas again. It's just a different way to get there than we've learned in the previous 2 examples.
So the next thing we want to do is define the acceptable tree species. The first thing we're going to do is clean up our map or our analysis page that we're working on. So I'm going to first turn off our good maturity, and I'm going to scroll down and turn off our maturity layer here. And because the layer we're going to be working with is species, I'm going to turn that one on. Okay. So next we're going to use a different tool to pull out, in our particular case, it's going to be the tolerant hardwood here and the unclassified hardwood. So the ones we're interested here are these yellow ones, as well as these kind of teal color on my particular screen. Okay, so the tool we're looking for is going to be reclassify. So you're going to go up here to the analysis tab, to the tools. Okay, then you're going to type in reclassify. Again, you're going to notice there's two options. We're going to pick the spatial analyst one. The raster file we're working with is our species layer. Okay. And you can see by default, the reclass field is automatically populated. And you can see all of the unique values of those species are listed below. Okay. So again, remember the only ones we want to keep are the tolerant hardwood and the unclassified hardwood. So what we're going to do is we're going to select on the ones we're not interested in keeping. Okay. So in this particular case, it's 1, 2, 4, 6, and 7. We're going to leave the no data there as well, because anything that's no data, which is this gray area out here, we want to remain as no data. Okay, so when I have them selected, I'm going to hit the delete key on my keyboard, and you'll notice they just disappear. Okay, if for some reason it doesn't seem to work on your machine, this is sometimes the case if you're using VLab. If you just want to type in no data in each one of those ones that we don't want, you can just copy and paste it from here. Okay, but anyway, mine deleted fine. What we're going to do is we're going to say either one of these cases are good for us, so we're going to put in a new value of 1, okay? Regardless if it is tolerant hardwood or unclassified hardwood, it's going to get a value of 1 in here, okay? So the output raster, this time, we're going to call it, if we get rid of everything by default, that's fine. It's going to automatically put it into our project geodatabase, our capesplit.gdb. We're going to call this good underscore species. Okay. And I'm going to make sure this actually is 1. You have to hit 1 and enter to make sure it gets entered in there. Okay. So my bad. Make sure it does have 2 1s up here. The other thing that's really important to do is check this box down here to change the missing values to no data. So those ones that we deleted, we want them to have the value of no data. Okay, so when we have this done, we're again going to hit the run button down here. It'll take a moment or two, and hopefully you could see that the unclassified hardwood and the tolerant hardwood, which were the yellow and the teal color, are now changed to this purpley color. Okay, so it appears our tool has worked, but again, if you do want to do some checks, you can go over here to your map tab, explore, and then we can click on one of these purple ones, and you can see here the good species is species 1, okay, and the actual species, if we go down here, it was the tolerant hardwood. So remember, tolerant and unclassified hardwood, we wanted to have the values of 1. If we clicked on something that's outside of this purpley color, so let's say this limey green one, you can see the good species is no data. If we click on the species, it is intolerant hardwood. So that was not one of our options that were considered good species. So again, it appears that our tool has worked as expected.
Now that we have where all of the criteria are true, meaning our good maturity, good species, and good slope, we should now be able to find our acceptable picnic locations. So what I'd like you to do is turn off all of the layers except for our good criteria, okay? So make sure good maturity, good species, and good slope are turned on in the context pane on the left side, and make sure everything else is turned off. What I'd like you to do is turn the layers on and off to get an idea where the ideal place is going to be. Remember, the ideal place is where it meets all 3 of our criteria. But how do you identify them so you can see only the good? To do that, you're going to go to the Analysis tab again, to the Tools button, and you're going to search Raster Calculator. Okay? You're going to select the Raster Calculator Spatial Analyst.
Now that we've met all three criteria where they exist individually, we need to figure out where they exist together. So what we're going to do is I'm going to zoom out to the entire area. I'm going to turn off the species layer. Okay, so now I only have the good species on. And I'd like to turn that on and off with these other two, good maturity and good slope layers. Okay, so again, if I turn this purple off with the pink underneath, you can see there's a lot of values that match there, as well as some over here. Okay, and then I'm going to turn on this red one, and I'm going to turn off first the pink one and then the purple one. And again, you can see there's some overlap between the purple and the red, which is the same place where they overlapped before. Okay, so it does, and then again, if I turn the purple off and I turn the pink back on, there does seem to be a lot of overlap. So there does appear to be some overlap up here and maybe some down here. So now that we had a decent idea where our most likely points are going to be, we can now go find the correct tool. So we're going to be using the raster calculator again. To access it, we're going to go up here to the Analysis tab. We're going to go to Tools again, and we're going to look for the raster calculator. Okay, again, because we're dealing with rasters and the license we checked was our spatial analyst, that'll be the one we use.
Now we need to figure out the equation to find where there's good slope and good species and good maturity. Okay, so this is going to be a more complex equation than we've dealt with in the past. So what is the expression? Again, we're going to be using the conditional statement, so con, but this time we're going to be looking for conditions in 3 different files. Okay, and each one of these conditions has to be in its own set of brackets. So the way this runs is con open bracket, and that's for the full condition. Okay, then you need a round bracket against the first condition we're looking for, which is good species equal to 1. And then you're going to close that bracket. Then you're going to use the ampersand for and you're going to open up the bracket for the next criteria, which is good maturity equals 1. And then you're going to close the bracket on that. The third criteria, you're going to type ampersand and then enter the third criteria, which is open bracket, good slope equals 1. Close round bracket, comma. What to do if all of those conditions are true, you're going to put the value of 1 in. And then you're going to close the bracket, the main bracket for the conditional statement. The output raster we're going to create is something called acceptable. So here is a screen capture of the raster calculator tool. Again, the equation that's in there is con open bracket, second open bracket, good species is equal to 1, close bracket, ampersand, open bracket, good maturity is equal to 1, close bracket, ampersand, open bracket, good slope is equal to 1, close bracket, comma. So those are all the conditions you're looking for. And then what to do if it's true, you're going to put in a value of 1, close bracket. The file that we're going to create is called acceptable.
Now we're ready to find where all 3 of the criteria exist at the same time. So this time, again, we're going to use the conditional statement. So we're going to go over here to the left side under Tools. We're going to find the con tool. Okay. This time, though, the condition we're looking for is actually much more complex. So what we're going to do is we're going to put each of the criteria that we're looking for in individual brackets. Okay. So you can see around the entire parameter or the entire expression here, we've got brackets around the con tool, but we're going to put individual brackets around each condition. So the first condition we're looking at is where the good species, and I'm going to double click it here, and then we're going to make sure we're on the correct side of of the comma, and we're going to find is equal to. So again, asking if it is equal to is a double equal sign. So I'm going to click that, and then I'm going to type in the number 1, because again, all these true values had a value of 1. So I'm going to close the round bracket, and then I'm going to use the ampersand sign for the and, because we need it for all 3 of these criteria to be true. Okay, so again, if you go through here, you'll see the ampersand. So this is the and. The line underneath it is actually the or. So again, we're looking for where all 3 criteria are the same. So again, I put the and sign in. I'm putting another round bracket, and this time we're going to be looking up good maturity. Again, is equal to, and a value of 1. And then another ampersand sign. So again, we need all 3 of these criteria to be the same, or to be valid. Okay, so again, I put the round bracket in, good slope, and we're going to go up to the equal sign, is equal to 1, close bracket. So you can see the way this statement reads so far is the condition we're looking for is good species equal to 1, and good maturity equal to 1, and good slope equal to 1. What do you want to do if it's true? We're going to be on the other side of the comma, and we're going to make it value of 1. And then we're going to have the close bracket to close on the initial conditional statement. So what are we going to call this output raster? Well, I'm going to call it acceptable. So again, if I remove everything, it's automatically going to put it inside of our project geodatabase, which is called Cape Split. So I've got all the information in, and I'm going to hit the run button here in the bottom right corner. Okay, when it finishes, you can see here it came up in gray. I'm going to adjust the color again. Maybe this time I'm going to put it in maybe green, a dark green. Okay, I'm going to turn this off so you can see that the green actually all appear on the purple, which is good. And you can see it was in those 2 locations we thought it might be. But again, if I turn on the good maturity, you can see the green and the pink overlap. And if I turn it on the red, the green and the red overlap. So again, you can turn it on and turn it off. So you can see now that we found where all 3 of those criteria existed, and logically it makes a lot of sense.
So what's our next step? If you remember our scenario, we wanted to show our acceptable picnic park locations over top of a hillshade. But what is a hillshade? Well, it's a hypothetical illumination of a surface represented by shadows on a map that simulate the effect of the sun's rays to create a 3D effect. So in order to create this hillshade, we actually need the digital elevation model. So that's going to be the data set that's going to be our input, so it can create this simulated shadowy effect. So what we're going to do is clean up our map a little bit. So we're going to turn off all of our layers except for acceptable. So you're going to uncheck good slope, good maturity, and good species, and make sure the acceptable layer is turned on. Next, we're going to find the hillshade tool. Again, to find the tools, you're going to go to the Analysis tab, Tools. You're going to search for hillshade. You're going to select the Hillshade Spatial Analyst tools. The input raster for this is going to be your DEM. Your output, I'm going to suggest calling it HS for hillshade. The azimuth, make it somewhere in the northern hemisphere. So just to understand how the azimuth works, imagine a compass, okay? So 0 is actually due north, okay? So that would be 90 degrees would be due east, 180 would be due south, and 270 would be due west. So 315 is the sun, which is the default, is the sun coming from the northwest quadrant, okay? This is a wonderful default, and I would leave it at that. The altitude, I'd like you to enter 45, and this is how high this fake sun would be in the sky to create these shadows, okay? So that's again, to help model this simulated shadow effect. We're going to leave the model shadows unchecked, and our Z factor, we're going to leave that at 1.
Now we're going to create the hillshade. So we're going to turn off everything except for acceptable. So there, in this case, I just need to turn off the good slope. So I'm only left with the acceptable. So now we need to find the hillshade tool. Again, we're going to the Analysis tab and the Tools button. And the tool we're looking for is called hillshade. Okay, again, there's 2 of them, and because we're dealing with raster, we're going to focus on the spatial analyst one, as we know we have the license. So our input. So if you're creating shadows, the shadows is based on the elevation of the data, okay? So therefore, our input raster for this is going to be our digital elevation model, or DEM, okay? Our output raster, I'm just going to call it HS for hillshade. The azimuth and altitude, I'm going to leave them at default, okay? We're not going to worry about modeling shadows or the Z factor. The Z factor would be if your elevation was different unit than was your projection. In our case, they're both in meters, okay? But if you look at the azimuth, we're going to leave it at 315. But I had said that it should be somewhere in the northern hemisphere. So where is the northern hemisphere? Well, it turns out the way that Esri or ArcGIS Pro measures it is from due north. Okay, so if you think of a compass rose or a circle, north is straight up. So anything in the northern hemisphere would be anything from 0, which is north, all the way over to 90 degrees. Okay, so that would be considered in the northern hemisphere. But if you think about the western side, so if you continued around your circle, due south would be 180, due west would be 270. So therefore, values from 270 all the way up to 360, which would get you into a full circle, would take you back up to north again. So 315 is in fact in the northern hemisphere. It's coming from the northwest. Okay, so we're going to leave that as the default. We're going to leave everything else here as good to go, and we're going to hit the Run button. Shouldn't take too long, and you'll notice we're getting the hillshade here. And what we're going to do is we're just going to place our acceptable value above it, so you can see where on this hillshade the acceptable values are. And if you take a look, this hillshade is actually giving you quite a bit of information. You can kind of see what's hill and what's valley. You can see here appears to be some hills and valleys here with probably what would be a river running through it. Okay, so again, the hillshade helps people understand what they're looking at, maybe a little clearer than looking at either the digital elevation model or just even the acceptable layer.
I'd like to emphasize the hillshade a little bit more, make it a little bit stronger. So how do I do this? So we're going to right click on HS in the contents pane on the left side. You're going to choose the symbology option. The symbology pane opens up on the right side. You're going to change your stretch type to standard deviation.
We're going to spend a little bit of time emphasizing this hillshade. So how do you do that? We're going to right click on hillshade in the contents panel on the left side. We're going to choose the symbology option in the pop-up. This is going to open the symbology panel on the right side. So what we're going to do is we're going to change the stretch type to standard deviation from none. Okay, so again, there's your standard deviation, and you can see it really truly emphasizes the dark and the white. So the way the standard deviation stretch type works is it doesn't actually change the value of the hillshade. It just removes the tails of it. So basically, the very biggest numbers and the very smallest numbers will automatically go to either the lightest or darkest color. So therefore, there's more shades of gray shown in the middle.
So what I'd like to do is add some color to our hillshade. So to do this, you're going to have to drag the DEM above the HS or hillshade in the content pane on the left side. Then I'd like you to right click on the DEM. In the pop-up, you're going to choose the symbology option. Again, the symbology pane is going to open on the right side. And I'd like you to choose a color scheme that you think is appropriate for showing elevation. Then we're going to make this color transparent so you can see both the color as well as the hillshade. So again, you're going to make sure that the DEM is selected in the Contents panel on the left side. You're going to click on the Raster Layer tab at the top of the screen. You're going to adjust the transparency probably to about 50% and take a look at your map and what's happened there.
We're also going to add some color to this hillshade, again, to make it a little more intuitive to what people are looking at. So how do we do that? We're going to go over here on the left-hand side in our Contents pane, and we're going to drag our DEM from the bottom to the very top. Okay, just above, actually not to the very top, pardon me, just above the hillshade. Okay, and we're going to turn it on. Okay, we're going to right-click and we're going to go to the symbology. Okay, and you can see the symbology panel for the DEM is already opened. We need to adjust the color scheme. We don't want it from black to white. We want it to be something more intuitive for the land. Okay, so I'm going to use my drop down and I'm going to scroll down here until I see some reasonably landish sorts of colors. So I'm going to pick one of these ones here. And I don't actually really love that one, so I'm going to pick a different one. Maybe I'll scroll down a little bit more. Maybe something like this one here. Okay, so the lowland is the green, and then the highest areas are the brown color here. So you can see we've got the color on, but now we've lost the whole point of having the hillshade in there. So what we're going to do is we're going to make this top layer transparent, okay, or this DEM layer. So to do that, we're going to make sure the DEM is selected here, which it is. Then we're going to go up here to the raster layer option. We're going to adjust the transparency to about 50%. So you can use the arrow, or in my case, I'm just going to type in 50. Okay. And you can see what's happened is now that the color has been made partially transparent, you can see the hillshade that falls below it. And you can now see that the good picnic parks actually tend to fall on this crest, so you'd actually get a really good view besides being a good picnic park. So I'm going to adjust this acceptable color just to make it stand out a little bit more. So I'm going to maybe make it, I'm going to make it red. Okay. And therefore you can see here where the best part locations for our picnic park are, and as a side benefit we know that they should have a good view because they're nice and high up.
It's important to give credit where credit's due. This presentation was developed using Esri's virtual campus course called Working with Rasters in ArcGIS Desktop. Additional information was taken from John Porter, Raster and Vector, at the link listed below. If you're interested in the GIS Center and what we do, we are located on the 5th floor of the Killam Library in behind Special Collections. My name is Jennifer Strang. You can send me an email at jennifer.strang@dal.ca or give me a call at 902-494-1386. If you'd like to book an appointment, you can do this online. To do this, go to www.dal.ca/GIS, and there's a book an appointment link there, and you can book an appointment with any of us in the GIS Center.